Hello, my dear students. In this session, we are going to revise the data objects available in the VHDL and next data types available in the VHDL. Okay, all of you know the data objects available in the VHDL. Okay, what are the data objects available in the VHDL? They are constants, variables, signals, and the file. Okay, all of you know what are the constants. Constants are uh, the, the values remains constant throughout the program. Okay, and I have written the declaration of the constant syntax, and here it is the examples. Okay, and next, what are the variables? The variables are locally stores the temporary data and it is used only inside a sequential statement. That means, what are the sequential statements? If the statements are executed line by line, then they are called the sequential statements. In the VHDL, the sequential statement is the process is called the process is a one statement that you are going to study in the next video. Okay, that is a one sequential statement. In that sequential statement, we are going to use the variables. Okay, in the functions also we are using, and in the procedures also we are using the variable declaration, and this point is going to explain you the syntax of the variable declaration, and here it is the example. Actually, all the things we studied in the previous video, just I am revising here. 1 and the 2 points are the extra points are there here, and this is what your signal. What is the signal? The signal represents the interconnection wires between the ports. Okay, it may be declared in the declarative part of the packages, entities, and the architecture parts and the blocks. Okay, where you are going to declare the signals? We are going to declare the signals in the packages, entities, architecture, and the blocks. Okay, mainly we are using this entity and architecture in our syllabus. Okay, that you are going to see in the next video, how we are going to use the signal in the entity and the architecture part when you are writing the VHDL program. Okay, and this part is going to explain you how to declare the signals. Okay, next are the file type, and next is the important topic in the uh, VHDL is the data types. What are the data types? Okay, till now what we studied the data objects. Data objects in the VHDL can hold a value that belongs to a set of values is called the data types. Okay, till now what we have studied the data set, the data objects. No, that data objects hold the value that belongs to the set of values is nothing but what the data types. In the VHDL, they are the some specified data types are there, predefined data types are there. Okay, let us study one by one. First one is the, let us study first the categories of the data types. In the VHDL, mainly there are four categories are there. Okay, in the VHDL, there are mainly four categories are there. In that, first one is the scalar data type. Second one is the composite data type. Third one is the access data type. Fourth one is the file data type. Okay, how many data types are there? Mainly, there are the four categories are there. Okay, they are the scalar, and next they are the scalar, composite type, access type, and the file type. Okay, once again this scalar type is divided into these four types. First one is integer data type, real data type, physical data type, and the enumerated data type. Composites is divided into two types, that is array and the record type. Usually this access and the file are called the advanced data types. Okay, this is about the categories of the data type. Actually, what happens in the VHDL, we are having the predefined data types and the specified data types. In that, first one is the four broad categories of the data type. Four broad categories of the data types are the scalars, composite, access and the file. Okay, let us study in this video what are the integer, real and the physical data types. Okay, what are the integer types? So all of we know the integers. Integers is nothing but what? The whole numbers. Okay, so that is why what it is saying here, it includes all the simple types such as the integer. So this is exactly the same as the mathematical type. Usually integers where we are using, in the mathematics we are using more, so that is why it is given that in the how you are using the integers in the mathematics, in the same way here also we are using. All the mathematical functions like addition, subtraction, multiplication and divide apply to the integer types. And another one important point is here, values belonging to this integer type is also called the integer literals. Okay, so what are the integers? Integers are the whole numbers. The same meaning is there and the same concept is there what we are using in the mathematics. Okay, so here also we are using all the functions what we are using in the mathematics. They are addition, subtraction, multiplication and the division. And next point is the values belonging to an integer types are called the integer literals. Okay, here I have written the some example for the integer. So you can see here the whole, and using the exponential also you can write, and using the dash number also you can write. These are the some examples for the integer values. And next point is here the range is given for this integer values. What is the range means? It is minus 2 to the power of 31 minus 1 to plus 2 to the power of 31 minus 1. Okay, just if you are evaluating this value, you are going to get this whole number. Okay, just to try this. Okay, this is about the integer type, and next one is the floating point type. Okay, we know that what are the floating points? Floating points is nothing but they are the real numbers. Okay, here for your understanding I have written the example. So if you have write the 16.28, 0.01, 0.002, these are the some examples for the floating point numbers. And the range is also given here. What is the range? It is 1.0 e to the power 38 to plus 1.0 e 38. Okay, this is the range for the floating values. Okay, and once again what happens, this values belonging to this floating points is also called the floating literals. Okay, and next point is this floating point and the integer values also can be written in base of other than 10. Okay, base of other than 10 also we are going to write. So how we are going to write that you have to find out and do the assignment for this one. Okay, next let us study the physical type. Actually, what are the physical types? So, if you want to represent any physical measurements, if we want to represent any physical measurements of the physical quantities like length, time, voltage or the current values, to this type are expressed as a integer multiple of the base units. Okay, they are called what? Your physical types. Okay, before going to study this example, let us study the predefined data types available in the VHDL. Actually, predefined available data types are the integers, operators, boolean, logical operators, and these are all present in the standard package. Okay, so you can say that boolean is nothing but you are going to say that it is 0 or 1, true or false. In this way we have studied all the operators, no, that operators are also present in standard package. Okay, and integers also present in the standard package. Other than this, what happens, this language is going to provide you to create the new data types using this type declaration. Okay, this VHDL is going to provide you to create your own data type using the type declaration. Okay, so here I have written the syntax for the type declaration also. Okay, how you are going to write the type declaration? Only just you have to actually type is a one keyword. Using that keyword we are going to create our own data type. Okay, so for that you go here in the example of the physical data type. You see here I have written here the type, and the current is a user defined. Is a keyword, range 0 to 1e9. Current is of the data type, it is type. Okay, it is of the type, so current is a type, is a one data type I have created. Okay, current is of the data type. Okay, it is ranging from 0 to 1e9. And next we have written the units, and afterwards I have written it is uh, NA, that is nano ampere is nothing but it is a base unit, and micro ampere is nothing but it is of the type 1000 of nano amperes, and ampere is equal to 100 milliampere. End units. Okay, this is going to explain you the example for the physical type and also the example for the type. Okay, so actually in detail also how we are going to use the type and how you are going to write the programs, that you are going to study in the coming videos also. Okay, so these are the predefined data types are there, and here let us end this video and do the assignment what I have given to you. Okay, let us meet in the next video. Hmm? Thank you, students.